Hello, today we are going to learn about types of the sets. Let's see the types of the sets. Now types of the sets are based on number of elements of the given set, and number of elements are written in a specific way. We write small n and in the bracket we write whatever the name of the set, and then whatever we get, it's a natural number. Whatever here we number get, it's always a natural number. Now let's see what are the four types of the sets. The first type is called singleton set. The name only suggests you this word in the singleton, that this type of the set has only a single element, of course, which will satisfy the given condition. So a set having single element is called singleton set. Let's see some examples of it. A set of whole numbers less than 1. Now whatever set given in the normal word form, or if it is given in the rule method, always try to convert into listing method. So if you want to write this set in listing method, what is set A? Whole numbers. So we know the whole number start with 0 and after that 1, 2 and so on, but we want less than 1. So less than 1, there is only one whole number and the whole number is 0. So this set contains a single element 0. Okay, so how many elements are in this set A? So number of elements in set A is 1. As we have the number of elements in set A is 1, that is single, this set is called as singleton set. Let's see one more example. A set of even prime numbers. We know the prime numbers are such that it has only two factors, 1 and the number itself, and the prime number starts with 2 and then 3 and then 5, 7, 11 and so on, which has only two factors, the number and 1 itself. Okay, 1 and the number itself. Now out of these prime numbers, we know that 2 is the only even prime number. So set of even prime numbers, though it is mentioned here numbers, we have only 2, which is even also and prime also. So this set contains only one element. Therefore, number of elements in set B is 1. And as this is one single element, we call it as singleton set. Now let's go to the second type. Second type is empty set or null set. Here again, the word empty or null suggests that it has not a single element which satisfies the given condition. Now this set we can write using symbol of only two curly brackets, opening and closing, and in between nothing in it. Or we can use the symbol, we can draw it by writing first O and then vertical line, called as phi. Okay, so this is a Greek alphabet phi, which is used to show empty set or null set. Either this or this, don't use both at a time. Okay, let's see the example. A set of natural number less than 1. This is similar to this. Here it was a set of whole number less than 1, and here it is natural number less than 1. But as we know the natural number starts with 1, there is no natural number less than 1. So this set A has no element in that. So set A is nothing. As the number of elements in set A is 0. 0 means nothing. It is not having a single element also. That's why it is called empty set or null set. We can, if the number of element is 0, then we can say A is like this as empty set, or we can say with the symbol phi, A is empty set, phi or null set. One more example, a set of natural numbers between 4 and 5. And there is no natural number between 4 and 5. So again this set, we can say set B it is, this is an empty set. Or we can say B is phi, having empty set, because number of elements in B are 0. There is no number which is between natural number between 4 and 5. You can replace this word natural by whole, still it is empty. If it is integer, still it is empty. But if it is rational number, then surely it is not an empty, because there are infinite rational numbers between any two rational numbers. Then in that case it will not be an empty set. Now let's go for the third type, it's finite set. Finite means if the set is having limited or countable elements, then it is called finite. Means if you start counting, it will stop somewhere. Then it is called finite set. So what is the example of this? A set of natural numbers up to 100. So natural numbers, when we start with 1, but it is not going, we are not going to till infinite. We are going to say up to 100. So there is a certain upper limit. So starting with 1, 2, 3, 4 till 100. So there is a limit. So here the numbers of elements stops at 100. We can count or they are limited. Hence it is a finite set. Again now this word natural, if replaced by whole or integer, still it is going to be remain finite. And if it is rational, it is going to be not going to be finite. And if it is not finite, means the elements are not limited, not countable, they are unlimited or uncountable, then it is the set is going to be infinite. The same example, a set of natural numbers, whole all natural numbers, or a set of